Okay, I've never actually seen one in person. This is the Definitive Technology SuperCube III. It's a little bit smaller than I was expecting for such a high-powered subwoofer. Very nice looking piano black on the top, as you can see. I believe piano black on the bottom. And verify that this is a SuperCube III. Power field, yes. Nice units when they're working. A bugger to troubleshoot when they are not. No serial number, which leads me to believe that maybe the internals on this unit have been replaced at some point in its life. Once again, very nice looking unit. So, haven't even plugged this thing in. Came in way too long ago. Once again, very, very backed up on these things. So let's go ahead and get into this unit, and I think I'll just power it up first and see what it has to say. Okay, well, I have the unit set up right here. I guess I could actually flip it over so you guys can see it better. One moment. And we'll try to get the camera aligned here. Okay, I think that's pretty good. So I have an MP3 player connected right here. I do have the level control at minimum, the crossover in the center, and then the phase alignment at 0. Power has not been applied yet. So here we go, power on. Let's see what's going to happen. It did draw some current. That tells me the main AC input fuse is not blown. Now we'll wait typically 30 seconds or so. Once it detects audio and the analog to digital converter stabilizes, it will apply power to the main power amplifier. So we'll give it just a moment and see what we get. And look at that, we got a click. And you can see the power LED did light up. It is drawing a little bit of current that tells me the power amp is good, but I have no audio absolutely whatsoever. Now the pots have been a big problem on some of these early versions of the SuperCubes, but we have absolutely no sound at all. So let's go ahead and we'll just try the LFE input. And I still get absolutely nothing. But that is a very good sign. That tells me the low level board is actually working correctly. And let me make sure that we do have current audio going into the unit, and yes we do. We should be getting sound out of the unit at this point. Okay, time to tear this thing to bits and see what might be going on in here. Okay, so here's a pinout of the what they call the low level board. So I'm interested in pins 1 and pin 2. Pin 1 is ground, obviously. Pin 2 is the pulse width modulation signal. They label it as PMA, and it comes from this little op amp over here, U3C. So basically it just turns on Q1, which is a 2N 3904, just switches it on and off. So I need to look at that signal with a scope and see if I'm getting any audio over here on pin 2 that goes to the power amplifier. So let's go ahead and get the scope set up, put an audio signal into this thing. So one thing I know for sure is that my P32 volt and my minus speaker relay is working, because that is what actually turns on the power amplifier from the low level board. So they have what's called the low level and the high level board, which I've got them both set up right here. This is considered the low level board, and this is the high level board. And so here's the connector that runs from the low level to the high level board, or the power amplifier here. And this little LED on the back right here is actually connected in series with the speaker relay and the power 32 volt signal right there. So I'm going to get a scope set up, put some audio into this, we'll probe it and see if we get a pulse width modulation signal, which is what turns on and off these 4 FETs alternately in a Class D operation or a digital amplifier. So this right here is the thermal sensor, and actually mounts to the back of the magnet on the speaker, which you can kind of see over in here. And incidentally, if you have one of these things, it is a 30 ohm resistance, not impedance, 30 ohm DC resistance for the speaker itself. Okay, let's get a scope hooked up, and I'll try to get a capture, and we'll see what we're dealing with. One moment. All right, there's the view of the scope. Let's apply power. And what I want to see is a square wave, which I do. And I want to see about a 50-50 duty cycle on the square wave. Once it achieves about a 50-50, it's going to power the amplifier on. You can see it's kind of moving, kind of breathing in and out. And so if you looked at the SuperCube Trinity that I worked on, when I supplied audio into it, you could actually see the audio as the square wave pulse width modulation modulates. There it is. It just powered on. I heard the click. So I do have audio currently going into it, and I'm turning up the volume, and I get absolutely nothing. So these things should be dancing around like crazy. The pulse width modulation should be changing, and it is not doing anything at all. So that tells me the main power amplifier is in good condition because it does power up. It's not shorting any FETs or blowing any fuses. I don't have excessive current draw, and I'm not seeing audio on that pulse width modulation signal. So I need to go back and troubleshoot this low-level board and find out what might be going on with that. I suspect either it's got a bad pot, which I've had many, many times, or because this is a later version and they stopped using radial leaded capacitors, they're using surface mount capacitors, it most likely has a high ESR capacitor. That's just my guess at this point. So I think what I'm going to do is flip this thing over, and I'll probe the audio going in and out of the pot and see if we have audio going in and out of the volume control pot, the main volume pot. Now, unfortunately, I have my lights off right now, and when I turn the lights back on, it's going to wash out some of the scope capture, but you can still kind of see it there. So one moment, we'll get a scope capture of the audio going into the volume control pot. Okay, probing the audio going into the volume control pot. Okay, so I'm looking at the pins of the pot right here, and it looks like I see audio there. Let me pause this, and it does stop. Looks like the time base is way too high on this thing, so let me get a probe on there, and then we will drastically slow down the horizontal time base so we can get into the audio level. Let's see where we are. Let's get to a different track here. And I've got nothing now. What's going on? Oh, it's still on. Oh, I paused it. My bad. Okay, there's actual audio. And that's on the input side of the pot. And then we'll go to the center pin of the pot. And I do have audio coming out of the center pin of the pot, as you can see right there. Now, I'm not sure what the other half of the pot does. It's actually just changing a DC voltage, it looks like. And both halves are working just fine. So I'm going to turn this up. And what about the crossover level right here? Trying to do this without touching anything. So I do see audio there. And I do see audio there. And I think one of these is grounded. I think this is only like operating as a rheostat. Okay, that's interesting. As I touched that pin, I started to get just a little tiny bit of audio. You can hear it there in the background. Very low level. This thing should be booming right now. That was very strange. And now the audio is back. What is going on with this thing? I think I'm going to power it down. And I'll try to repower it on. Power has been reapplied. Turn this down just in case. Because that was just the impedance of the probe. I do have it in ×1, so it's not in the ×10 mode. I'll wait for this thing to power back on and see if we still get audio after power up, even though it's extremely low audio. I might try heating the capacitors. If it's got a bad capacitor, if I heat them up, it normally helps with the ESR. Yeah, now I've got nothing at all. So just for the heck of it, let's do that same thing again. And I've got very, very low level audio. Interesting. Well, let's go ahead and heat these things up and see if we can find one bad capacitor. It's probably going to have to be completely recapped. And these are kind of a really fun time to recap with all the surface mount. And of course with all the glue. Does not help matters at all. Okay, so I've got my hot air rework station heating up right here. And I think we'll only take it up to, well, we'll take it up to about 250, 300 degrees, somewhere in there. Okay, here we're at 250. Get the audio set kind of in the middle here. Checking my MP3 player. Audio is playing. I know there's like one cap buried way back over here. I should just go ahead and ESR these capacitors and see what they might have to say. I know there's a couple more hiding over here on the side. Probably just barely see them off camera. I don't think it's got a power supply problem. I think it's going to be a low-level signal processing issue. Okay, let's see if that did anything at all. And I still have no audio at all. We're exactly the same. I'm going to check those pots. Maybe it's just got a bad pot and all the caps are good, because that should have made some kind of a change. One moment. Okay, got my 87 set up right here on ohms. Well, verified lead integrity is good, 0.02, that's perfectly fine. So I just want to measure the outer pins on that pot. Hopefully you can see it. And I see 4.7K and 4.7K there, about 5K. Now it's turned down all the way, so I should get basically 0 ohms there, and I do, and I should get 0 ohms here, and I do. So this is the one that was doing the weird stuff, the variable low pass. So I should get 0 ohms here, and I do, and I should get 0 ohms here, and I do. And that's not good. And that's not good. Turn it up all the way. And I should get 0 ohms. And I do not. There's the problem right there. That is the problem. So I have it turned up all the way, so effectively these two leads and these two leads, which you probably can't see because it's tilted, but I should get 0 ohms here. And look at that, it's in the megohm range. Well, I'll do that again so you can see it. They're both in the megohm range. That pot is bad. What about this guy over here? So we'll go from ground. That's not good either. Down all the way. So I think it's going to need a set of pots. I think it's going to need a set of pots. So, because this one's connected just as a rheostat, I'm just going to add some resistors to it. Let me find out what value that pot actually is. That's a 20K pot. So I'm just going to put a couple of 20K resistors across these two terminals on the side. One moment. Okay, so power has been removed. I'm just going to add some fresh solder to these two terminals. So I'm sure this is all lead free. These are actually 10K resistors. Tack one on there. Let it cool. And we'll tack one right there. Okay, happy with that. So this is just going to simulate that control is in the middle. We'll put it back there. I don't think we need to look at the voltmeter, but I'll leave it there just in case. Volume down all the way. MP3 player is playing. Power on. Please don't blow up, as Chris Stevens would say. Waiting for the power supply to turn on. Got my finger on the power button just in case. Power has been applied. Oh yeah. It's definitely doing something. Oh yeah. It is definitely thumping. It's shaking the whole speaker. It's actually walking across the workbench. Seems to have a little bit of distortion, so it might be that phase alignment pot is having a problem as well. But I think I can safely say that it needs a set of pots. And if there's other issues, once I have this board apart, we'll go ahead and ESR all the capacitors. If there are any defective caps, we'll go ahead and replace them at that time. You know what? Let me go ahead and add a resistor to the phase alignment, because that might be doing something as well. So the only pot I know for sure is good is the volume control. So I need to scrape this glue that they so considerably added to this board and get to those terminals. One moment. Okay, so I have the glue scraped off here. Hopefully you can still see the meter. Let's reset it so it doesn't time out. So I have the pot in the center right now, and I think that's a 5K. It doesn't say, I think it's on the other side. So it's in the center, so I should get about 2.5K. And so I get 0.2 ohms, so I know that these two leads are basically tied together. Whether they're ground or not is a different story. They're not ground, but they are tied together. And so from this lead to there, I should get about 2.5K, and I get 0.64 megs or 640K. Now if I turn the pot all the way to the down position, I should get 0 ohms here, and I still get 0.64, which is absolutely terrible. So I'm going to go ahead and add another resistor there. Now this one I think I'll just put like a 1K or something. It's the phase alignment pot. It's not too terribly critical. So let me get some solder and we'll tin this. I could actually put a jumper across this and it would just simulate having the pot at the one extreme. But just to be safe, I'll put a resistor across there. Okay, resistor has been added. Just want to make sure I don't have a short to ground now. And I do not. I have 156K to ground. And I should get 1K there, and I do. And then this should still be 0, and it is. Okay, so I'll put this pot basically in the middle. Make sure nothing is shorting anywhere. Actually, I'm going to flip this up like that so you guys can see the pots. Volume all the way down. Power has been applied. Start the MP3 player over on a different song that I know has bass. We'll let this thing warm up, stabilize, and hopefully we get distortion-free audio. So if I have distortion at this point, we're going to have to dive a little bit deeper to figure out what is going on with this thing. Make sure those don't touch. Oh, I have to actually press play. That does make a difference. Imagine that. What a difference. Let me tip this up a little bit. It's shaking everything. Holy crap. Well, with the exception of replacing the pots, it's fixed. But I mean, this thing has got some bass to it. I mean, it's walking. Well, I think I can accurately give the customer an estimate at this point. It needs a pot refill, as so many other SuperCube 3s have needed. Okay, I'm going to end part 1. Hopefully you enjoyed this video on the Definitive Technology SuperCube 3 power field. Bam! This thing does have some power. Wow, and it's such a tiny little footprint. Oh my gosh. Maybe the customer will decline this. I'll fix it, and I'll get rid of my Sony 150 watt subwoofer with this thing. That would be so awesome. probably not going to happen. Anyhow, just want to make a mention. If you saw 12 volt vids, 12 volt videos repair on a SuperCube Trinity's, or not a Trinity, a SuperCube 3. I think he got the schematic from me. Basically, I uploaded these to Hi-Fi Engine, and it looked like the same one, other than it was printed in black and white. And I think he found a bad cap. I recommended he check the pots. I don't know if he ever did. On another note, if you watch 12 volt vids and you happen to see a VCR he did about a month ago, when he opened the box, it had a little post-it note on it that said NorCal 715. I wonder if anybody else caught that but me. Yes, I watch other people's videos, not just my own. Okay, everyone, thank you for making it to the end of this video. I really, really appreciate it. I have a definitive answer on the Definitive Technology Powerfield SuperCube 3 at this point. Okay, thank you for watching once again. Everyone have a great day. Bye-bye. Okay, how about a little bit of bonus material? Let's look at that pulse width modulation waveform now that this thing is actually working and see what we get. Let me put this back in auto. It's what fills the screen correctly. We should get a nice square wave. Wonder if we have audio before I even... Oh yeah, look at that. There's the audio going in right there. See the booming. So we'll let it stabilize and power up. Hopefully the scope's kind of in view. I bumped my cell phone. There, power has been applied. The red LED is on. And you can actually see the pulse width modulation changing. That's good. Top fell off. No problems. Probably shaking the phone as I'm recording. Okay, little bonus material. Hope you enjoyed it. Everyone have a great day. Bye-bye.